Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 9, Lesson 5, the quadratic formula and the discriminant. You're going to learn a new vocabulary word today, discriminant, and we're going to see how to derive the quadratic formula to help us solve quadratic equations. Remember, that's finding the zeros or the x-intercepts of a quadratic function. For the explore and reason, we have these three quadratic equations. How many real solutions are there for each of the quadratic equations? So if we look at the first one, it's not a perfect square trinomial, so we'd have to complete the square to be able to factor that. But then we could solve for x and find the solutions. For b, it is a perfect square trinomial, so we could just factor it as x minus 3 squared. That means there's going to be one possible solution because it's going to be the same. And for the last one, same thing, it's not a perfect square trinomial, so we have to complete the square. Let's get out our graphing calculators and graph them and then actually see if we can find the solutions. So on your graphing calculator, go to y equals, and then we're going to type in the three equations. X squared minus 6x plus 12 is the first one. Second one is x squared minus 6x plus 9. And the third is x squared minus 6x. They all have the same linear term, minus 5. So just different constants. Let's graph it and see what we have. All right, so the first one does not cross the x-axis. There are no solutions for the first equation. No real solutions. For the second equation, the perfect square, we knew it would only have one solution because it's just at positive 3. And the third equation, it crosses at 2. So we have 0, 1, and 2 solutions. Part B asks to use our graphing calculators to graph them, which we did, and then what would be the functions if we reflected them over the x-axis? So if we reflect over the x-axis, then what would they be? Explain how we would find the function equations. So what would that graph look like? Well, B is easy. We just reflect it, so then instead of the vertex being up here at 3, 3, it would be at 3, negative 3. Okay. And the second equation, the red parabola, would just be downward facing. It would have the same x-intercept, it would just be downward facing. The third one would be a little bit different, but the x-intercepts would stay the same, but it just would be upward facing. Part C, what do you notice about the graphs that have 0 x-intercepts? Meaning the first one, and then when it's reflected over the x-axis. There are no real factors. We can't factor it and get a real solution, okay? And then again, if we factored the second equation, the red parabola, we knew it would be x minus 3, so we could factor it and get one solution for x. So when would we use the quadratic formula to solve equations? What kind of methods do we have to solve quadratic equations? We could use square roots. We could factor them and then use the zero product property. Set both binomials equal to 0 and solve for x. In the previous lesson, we learned how to complete the square to turn the trinomial into a perfect square trinomial that we could factor and then take the square root of both sides to solve for x. So we have 3 methods so far, but what if we can't factor it? What if we can't easily complete the square? There's another method called the quadratic formula. And all of this math is how we derive the quadratic formula. It's really just completing the square. So here we have a trinomial, and notice we're not using any values for variables. We don't have any coefficients. We're just using variables. But notice we're going to have a coefficient in front of our quadratic term. We saw an example of that in the previous lesson where we had to factor that out. So first step in completing the square, move the constant to the other side. That's what they did. And then since we have that coefficient in front of the quadratic term, we're going to simplify, divide everything by a. So if I divide everything by a, then I'm going to get 1x squared. I'm going to get b over ax, and I'm going to get my constant divided by a. So that's all we did. We just got rid of the a, divide everything by a. And now we're going to do our completing the square equation where we take b. Remember, b is just It's this whole thing, that whole coefficient, and I'm going to square it and divide it by 2. So we take b over a and divide it by 2, so now we get b over 2a, then we square it, and that's the constant we add to both sides. So far, all we're doing is normal completing the square. Maybe this step was a little different, going where we divided everything by a. And now we can factor it, so since it's a perfect square trinomial, we can factor it, and whatever the constant is, that's our second term in our binomial. So b over 2a is just our constant, that's what we add to both sides. And when we square that, we get b squared over 4, because 2 squared is 4 and a squared is a squared. So all they did here was they just squared whatever's in parentheses to give us this. Okay. Now we want to have common denominators so we can add these two terms together. So that means we need to multiply by 4a over 4a so that we have a common denominator. So we're going to multiply by 1, essentially, so we can have a common denominator. So we multiply our constant, negative c over a, by 4a over 4a. Now we have common denominator, 4a squared and 4a squared. We combine those now. We can combine those now. Well, they put the b squared first so that we don't have a negative. And so we combine our numerator since they have a common denominator, and now we're here. Okay, so far so good. So now, since it's a binomial squared, to get rid of the square, we take the square root of both sides, so that's what they did there. Okay, and don't forget the positive or negative. And remember, if you have a quotient under a radical, you can split it, so it really is the square root of b squared minus 4ac over the square root of 4a squared, and we can simplify the square root of 4a squared. That's a perfect square. So that's what they did here. They simplified that to be 2a. They just took the square root of that. And then you can see they moved the b over 2a, they moved that to the other side. So it becomes the opposite. And now look, we have common denominators, so we can combine the whole numerator and put it over one denominator. And this is what you get. You get what's called the quadratic formula. You're going to want to memorize this. So opposite b, think opposite b, not negative b. Opposite b plus or minus the square root of b squared minus 4ac. So you're going to multiply all of those coefficients all over 2a, all divided by 2a. Okay, so opposite b plus or minus the square root of b squared. Then you minus 4ac all over 2a. You can say that to the tune of Pop Goes the Weasel if a song will help you. And we get the values of a, b, and c from our standard form. ax squared plus bx plus c. You get those values from your standard form equation. Remember, it's already set equal to 0, so what is this formula going to solve for? It solves for x. It's going to give us the solutions, or the x-intercepts, the zeros of our quadratic equation. What is the maximum number of solutions for the quadratic formula? Well, what is the quadratic formula? We're solving for a solution, a value of x, or the x-intercepts, equals opposite b plus or minus the square root of b squared, then you minus 4ac, all over 2a. Well, right here is your clue. You're taking a number and you're adding something and then dividing by 2. So that'll give you one solution. Then you're taking that number and then you're subtracting a number and then dividing by 2a. That's going to give you 2 possible solutions. So at most, 2 solutions. We can have less than that, but at most we can have 2 real solutions. So how can we use the quadratic formula to find the solution? So here is our starting point. It doesn't look like a trinomial, but we can rearrange that as easily. Let's turn it into standard form. So let's move the 4x to the other side. And now it becomes negative 4x minus 7. So here we go. We have a standard form trinomial set equal to 0. We can solve this. Label your values of a. So a is that invisible 1 in front of the x squared. Label your b as negative 4. Label c as negative 7. And then we're just going to plug in those values into your quadratic equation. So write the quadratic equation. Always write it out first. Write it out and then substitute your values. So step 2, substitute the values. Remember, it's opposite b, so it's opposite whatever b is. Put b in parentheses. So it's opposite of -4, which is going to be +4. Plus or minus the square root of whatever b is, you square it. So this would be this, I'm going to write over here a little bit. Square root of 16, then minus 4 times a, so -4 times -7 is going to be +28. So that's what they did there. It's like an in-between step. And then 16 plus 28 is 44. So that's how we get the square root of 44. And then 2 times a was just 2, since a is 1. Okay, and now when you are getting your values, this is what's important. Make sure you're doing the order of operations correctly. You're going to do 4 plus the square root of 44, get an answer saved in your calculator, then hit divide by 2. Then you can round your decimal. And then to do the other, you're going to do 4 minus the square root of 44, get an answer. It's going to have a long decimal, then divide that answer by 2, and then you can approximate your decimal. So these are our values, or our solutions, our values of our x-intercepts. One at 5.32 and one at approximately -1.32. So a couple cautions. Make sure whatever b is, you put it in parentheses because it's opposite b. Okay, opposite b. And then it's going to be positive when you do b squared underneath the radical. And watch your signs for this -4ac. Watch your signs. That is a -4 times whatever a is times whatever c is. So it could stay negative or it could become positive. Let's try it. Find the solutions using the quadratic formula. So here's part A. I'm going to rearrange it. So I need to move the x squared. I'm just going to move the x squared over there. So it becomes -x squared minus 4x plus 21 equals 0. It's equal 0 now because I moved the x squared. And now I can solve it and find the solutions. What is A? A equals -1, B equals -4, C equals +21. Watch your signs. Okay, so I'm going to write my quadratic formula. X equals opposite B, opposite whatever B is, plus or minus the square root of B squared, whatever B is, I'm putting in parentheses, minus 4AC, all over 2a. So now I'm going to substitute. X equals the opposite of b. B is -4, so the opposite of -4 is +4. Plus or minus the square root of, b is -4, -4 squared is 16, minus, I'm not going to do my minus yet. So I have -4 times -1 times 21. I'm going to write this part out. All over 2a, 2 times -1 is -2. X equals 4 plus or minus the square root of, I'm going to have 16, -4 times -1 is +4, +4 times 21 is 84. All over -2. And now if we do that, we're going to just, in our calculators, we're going to do -4 plus the square root of 84, and then take your answer and divide it by -2. We'll get approximately, this is going to be our negative value, -7, because we'll have a positive number divided by a negative will give us -7. And -4 minus -84 divided by -2, this will give us a positive value, so that will equal 3. Let's do part B. It's important that you write things out. That way you don't make errors in your calculations. Okay, I'm going to move the 24 to the other side. So now it becomes x squared minus 2x minus 24 equals 0. A equals 1, B equals -2, C equals -24. I'm going to plug that into my quadratic formula. X equals opposite B is +2. Plus or minus the square root of B squared. -2 squared is 4. Okay, and then I'm going to do this. Minus 4 times 1 times -24. All over 2a is just going to be 2. Let's simplify underneath the radical. 2 plus or minus square root of, I'm going to have -4 times 1 is -4. Negative 4 times negative 24 is positive 96, all over 2. Okay, and then we can simplify. If we do 2 plus the square root of 96 divided by 2, we will get positive 6. And if we do 2 minus the square root of 96 and then divide that by 2, it's going to be a negative 4. So there are our solutions. Our application problem, finding approximate solutions. The function shown represents the height of a frog x seconds after it jumps off a rock. How many seconds is the frog in the air before it lands? So we're looking for that x-intercept, that solution. And we have our equation. We can identify A, B, and C. So A is negative 16, B is positive 10, and C is 0.75. So we're going to substitute those values into our quadratic formula. Opposite B is 10 plus B squared, 10 squared minus 4 times A times C, all over 2A. Simplifying underneath the radical. 10 squared is 100. Negative 4 times negative 16 is 64. So we're doing positive 64 times 0.75. That's 3/4 of 64. So what's 16 times 3? 48. So we're actually going to be doing the square root of 100 plus 48. We have that here. And 2 times negative 16 is negative 32. Then we can simplify. We have either adding it, where we add the square root of 12.17, sorry, the square root of 148. They've estimated it already right here, 12.17. And then you get the answer when you subtract the square root of 148. So can we have a negative value for t, which is time? That does not make sense in our real world situation, so this is not a valid or applicable solution. Does not make sense. So we know he's been in the air for 0.693 or almost 0.7 seconds. The height of another frog over time is modeled by this function. How many seconds is this frog in the air before landing on the ground? Round your answer to the nearest hundredth. Okay, so we're going to do the same thing. What are our values of A? A equals negative 16. B is positive 10. C now, different constant. Plug that into our quadratic formula. X equals opposite B, which is negative 10, plus or minus the square root of B squared, it's 100, minus, and I'm going to write this part out, 4 times A times C, all over 2 times negative 16. I'm going to let you simplify underneath the radical. I want you to practice doing that, but your solution then, the one that is valid, should be approximately 0.65 seconds. So if we do our calculations correctly and we simplify underneath the radical correctly, you should get approximately 0.65 seconds. Example 4, using the discriminant and what that tells us. So the discriminant is just what is underneath the radical, okay? Now, we can analyze that, and it can give us a clue to how many real solutions we will have, because let's think about it. Can we take the square root of a negative number? Well, we can't. So if our discriminant, or if what's underneath the radical, will give us a negative, then we know that's not a real solution. So another new word is roots. It's another word for the zeros of our quadratic equations. Roots are the input values for which the related function is equal to 0. So it's just another word for the zeros of the equation, the roots. So these points are called the x-intercepts, the roots, or the zeros, okay, or the solutions to a quadratic equation. But it's important to remember, if our discriminant, or the expression underneath the radical, if it's negative, if it's less than 1 or less than 0, then we don't have any real solutions, because you can't take the square root of a negative number. Okay? If the discriminant, if what's underneath the radical is equal to 0, then you take the square root of 0, you get 0. That means you're adding or subtracting 0. There's only one solution. If what's in the discriminant is greater than 0, it's some number, then you're going to add that number or you're going to subtract that number. You will have 2 solutions or 2 roots. Part A, let's find the number of solutions. We don't even need to solve it. We're just looking at the discriminant. Okay, so just the b squared minus 4ac. So plug in those values. B squared, negative 4 squared, minus 4ac. So this would be 16 minus 12. That gives us a positive value. We know that we're going to add 4 and we're going to subtract 4. So we're going to have 2 solutions. Part B, let's determine how many real solutions we will have just looking at the discriminant. So it's just what's underneath the radical, b squared minus 4ac. That's all we're doing. B squared is positive 4 squared minus 4 times a. Now a is negative. So we're going to get 16. Negative 4 times negative 1 is positive 4. Positive 4 times negative 4 is negative 16. Now we're going to get a discriminant equal to 0. It's possible you can take the square root of 0, so that means you're adding 0 or you're subtracting 0. You're getting 1 solution, 1 root, 1 x-intercept. Part C, I bet you can guess what this one's going to be. So if we just look at the discriminant, if we just look at b squared, so negative 4 squared, minus 4 times a is that invisible 1 times 5 is c. I'm going to have 16 minus 4 times 1 is negative 4. Negative 4 times 5 is negative 20. I'm going to get a negative discriminant. I can't take the square root of a negative number, so there are no solutions. That means it does not cross the x-axis. There are no x-intercepts. Try it number 4, use the discriminant to find the number of roots. So we don't even need to solve, we're just saying how many solutions will there be. Okay, so we're just looking again, b squared minus 4ac. For part A, what is b squared? It's negative 10. Okay, I'll write it out. Negative 10 squared minus 4 times 1 times 25. This is 100 minus 100 equals 0. So there is 1 solution, or 1 root. Part B, b squared, which is negative 6 squared minus 4 times negative 1 times negative 10. So I'm going to get 36. Negative 4 times negative 1 is positive 4 times negative 10 is negative 40. So now I'm going to have a discriminant of negative 4. There will be no roots, no real solutions, because we cannot take the square root of a negative number. We made it to the concept summary for using the quadratic formula and discriminants. So make sure you understand this definition, what the discriminant is. It's what's underneath the radical, and how many solutions or how many roots there are depending on the discriminant. If you have any questions, put them in the comments. Make sure to like and subscribe and come back for lesson 6.